Hello, everybody, and welcome on my behalf. I'm Nathan De Geyter, business developer at UGent, and together with Professor Erik Meers, who is the promoter of this RE-SOURCE.BIO community, we are going to illustrate what we do at the university and its partners with respect to resource recovery and what we do to try to tackle the organic waste problem. So in this presentation, we will cover the why, the how, and the what of not to waste. We will also talk a bit about the community and the different aspects of the community, how we are organized into different thematic working groups, and we will illustrate that expertise with some case examples of relevant EU projects that are currently ongoing, and also with another initiative that was started by Professor Meers called the Biorefine Cluster Europe, and then end with an open call that we're open for collaboration and opportunities to do something about our organic waste problem at the European level. So why not to waste, as you all know, and this short video of the FAO illustrates it perfectly. We are still generating way too much organic waste. So globally, that's approximately 1 billion tons of waste, of which an estimation is that 1/3 is still being landfilled, as you see here for these pumpkins. That's of course a double problem, because not only the opportunity costs of all the inputs that went into creating this food and organic waste, but also then the fact that they are landfilled makes that they contribute to greenhouse gas emissions and climate change. What is the solution? Where others see green waste, we see an opportunity to actually valorize that waste or that biomass into different sorts of applications and aspects of resource recovery, of course, according to an integrated biorefinery concept, where we have an eye for maximum value maintenance and creation. So we have organized ourselves where more than 35 research groups within the University of Ghent and its associated partners, so the Universities of Applied Sciences, have agreed to work together and join forces in 6 working groups. So focusing on nutrient cycling, but also water treatment and recovery, generation of energy, valorization of the fiber and the material, but also then the interesting biomolecules and chemicals for different kinds of applications, and then also to study the more socioeconomic elements and the sustainability aspect of all these R&D and innovations. So actually, fun fact, where the journey started is via a European Interreg project in 2011, and since then the community has grown and different initiatives were added by Professor Meers and his colleagues to end up with what we have now as a very big and working collaborating RE-SOURCE.BIO community. This can be also visualized via this scheme, so in which we have different value propositions, and we're working, of course, on research and education, but also business collaboration and also communication and stakeholder engagement as value for society, both at the regional level and at the European level. So for all of these aspects, different actually entities with different support people like myself for the business collaboration have been established. So just to give you an idea about the topics we work on, you can check it also later when we share the presentation. But so it's not only the nutrient recuperation and water treatment, but also generation of energy, also actually focusing on the conversion processes, the extraction or the separation of different kind of organic waste streams, whether that's thermochemically or biochemically, via fermentation, you name it. And then for some of these biomaterials and fibers, they can be used in textiles or construction materials, on which we have some research groups and projects, but also the biomolecules for different kind of applications, whether that's for food as natural dyes or feed formulations or agrochemicals, you name it. Actually, the combinations are almost endless. Then just to illustrate the EU leadership we have with this critical mass of research groups is that currently there are more than 25 running EU projects in which we are active, bringing in a lot of budget, not only for the university, but also for all the partners involved. More importantly, the success rate of our project proposals is a bit higher than that of the average success rate for the EU. So we estimate it to be around 30% over the period of the last 5 years. And that is, of course, because we have a dedicated support staff, both in project acquisition and implementation, and also because it's linked to this common and shared initiative called the BioRefine Cluster Europe, where a lot of joint events and joint communication efforts are organized. Also importantly, we work from low TRL levels, but also to quite high TRL levels, being 6 and 7 in, for example, innovation actions. Then I give the floor to Professor Meers to illustrate the technical expertise of the different working groups through some case examples of EU projects.
Yes, thank you very much, and also welcome on my behalf to this presentation. Indeed, I wanted we wanted to give you also a small illustrative flavor of some of the European projects. We are not going to go into depth of them. We don't have time for that simply, but you can contact us, of course, if you have questions afterwards. But indeed, we are covering a wide variety of topics on bioresource recovery, and we link these in the working groups. For example, on the working groups on nutrient recycling, one of the core projects that we have is Nutri2Cycle. It's a Horizon 2020 project in which we want to optimize the nitrogen, phosphorus, but also organic carbon flow across the different agricultural activities, plant production, animal production, looking at different crop types and animal husbandry types, but also interlinking with the food industry and interlinking with the processing industry. So, and looking at different ways and innovations on how to optimize and not to let it go to waste the nutrient flows across these. And of course, go to waste also results in reduced losses to the environment of such nutrients. So that's an added plus. Then linked to the but maybe you can link to the working group on biochemicals extraction. We have the ALG-AD project. That's an Interact project in which in Northwest Europe we want to look at how to move towards a next generation of biogas operations. So you have the energy production from waste. But in the ALG-AD project, they are also linking algal technology to anaerobic digestion, which means that from the digistates flowing from these biogas plants, algae are being cultivated, and these algae contain quite a lot of proteins, providing a novel protein source and again closing loops. The next example is from the energy working group, in which green carbon is investigated, waste being thermochemically being processed with pyrolysis or hydrothermal carbonization. You have carbon that is then converted into biochar, and this biochar is being investigated in a multitude of possible applications. This is in frame of a Marie Curie type of project. Marie Curies are PhD communities, and in this green carbon project, 14 different PhDs across Europe are involved. Glassification is a project in which roadside verges are being investigated. So, as you know, we have quite a lot of road sites, the bermmeisel in Dutch, and those verges need to be maintained at regular basis. And even for a small region like Flanders, this produces over 1 million tons of biomass each year, which is in essence is currently being treated as waste. But in gasification, we are looking at different ways of valorizing that into materials, into isolation panels. Also, energy is being looked into, and also nutrient recycling from side streams of those upcycling streams, because you always have processes in place, and every process has additional side streams, and from those side streams again you can refine further elements and values. So, and in this case, this is linked to the working group biomaterials, and very interesting grass-based biocomposites are being derived from that, and prototypes are being developed from those biocomposites in actual products. And on the next slide is also on a biochemical extraction, but in this case it's from marine biomass, in which chitin is being extracted from waste coming from crabs, shrimps, mussels, and so on. Well, the chitin is coming from the shrimps and the crabs. Mussels are for other types of extractions that you can do. So it's actually there is already an existing high-end market for chitin, but in this way you can more dedicatedly try to install and implement systems for more sustainable extraction from low-value currently treated waste products. The next example is from the working group on value chain and life cycle analysis. And in this case, it's a project called InSight. It's a SPIRE project under the Horizon 2020. And their core technologies are being investigated in which chemical processes and chemoenzymatic processes are investigated to produce new fine chemicals and bulk chemicals. But of course, as in any process, you want to not only look at the technical feasibility, but also the sustainable value proposal. So, and in that case, we have our own in-house experts in dealing with life cycle analysis of new processes. And then a seventh example provided here is Vegitech, and that's coming also being supported by an Interact project. And Vegitech is one of the novel platforms in which investigations and innovations in the vegetable sector are being investigated, and they're also looking, amongst others, at what can you do with the waste streams coming from food processing and conversions, but also, for example, the washing water that is involved in vegetable processing. What can you do in treating those waters, recovery, and so on. So this is just in a nutshell 7 examples, and I do apologize for scanning through them very quickly, but time is limited. You can contact us if you are interested in any of these. But as Nathan mentioned, we are involved in multiple projects. The BioRefined cluster is a collaboration platform actually between European projects, in which we bring together our competences on communication, and we have set up several common communication channels, websites, social media, monthly bulletin, and so on, but also organizing joint events and having a good loyal follower audience, and by doing things together between projects, reaching a stronger stakeholder audience. In the BioRefined Cluster Europe, we have a little bit more projects than we have at Kent alone, because we also have projects in which Kent is not involved that are joining the cluster from other partner institutes or from industries in which we have close collaboration and who want to join forces on the communication and dissemination part of things. We have partners across the entirety of Europe in that, maybe then the opportunities for this audience, we have already touched the different working groups that we are dealing with: nutrient recycling, water treatment and recovery, the bioenergy aspect, biomaterials and eco-design, biochemical extraction, and also the overall value chain and sustainability assessment. So if you are interested in any of these items linked to the bio-based waste part, so the bioresource recovery, then we might be a suitable partner for you. So, and then maybe the next slide. So waste is not a waste until we waste it. That's a lyrical approach. Or there is no green waste, only underutilized biomass. Or as Nathan at the beginning says, indicated, where others see an end, we see a beginning, we see an end of waste. So you can contact us if you are interested. And I think on the next slide you will see, will recognize myself and Nathan, but we also have a colleague Jimena who is working in our team. So you have the contact, the presentations will be shared, so you can contact us of course afterwards, or if you have questions at this stage, of course, also welcome.